Hello everyone, we are matrixcrafters, a team of final year students at JP University. We are currently pursuing BTech in CSE. We are thrilled to be part of Build for Bharat Hackathon. Today we are excited to present our solution addressing the foundation level problem in the retail and logistics theme, the optimal storage and retrieval in M cross and sparse matrix. The challenge presented to us was to devise a method for efficiently storing and retrieving values for each seller from a database in real time. As you can see, when we have a lot of data, it is hard to retrieve and write in real time. To tackle this, we embarked on creating a custom database tailored specifically to handle the complexity and problem at hand. Our database can be accessed in two convenient ways. Firstly, you can utilize the custom database query defined through our custom query processor. These queries are tailored specifically to a database structure, allowing you to efficiently retrieve, manipulate, and do other things to uh, the data according to your needs. Whether you are searching for specific records or complex data operation, our custom queries provide a powerful toolset for interacting with the database. Secondly, we offer an API that seamlessly integrates with ONDC and other related platforms or any other platform that you decide to work with. This API simplifies the process of accessing and interacting with our database, enabling seamless integration into your existing systems or application with just few lines of code. You can leverage the full functionality of our database within your own software, streamlining workflows and enhancing the productivity. Our product introduces a groundbreaking approach of managing pin codes efficiently, particularly relevant in sectors like retail and logistics. We have leveraged the power of tree structures to revolutionize storage and retrieval operations. Let's dive into the details. Let's go with this demo for now.
At the heart of our solution lies a sophisticated tree structure. Each level of the tree corresponds to a digit of the pin code. By organizing the data in this manner, we are able to exploit shared prefixes among adjacent codes. Consider three pin codes 543211, 543212, and 543213. In our tree structures, node represents digits, with branches extending only for differing digits among codes. This ingenious design minimizes redundancy and optimizes storage space. By adopting this approach, we have achieved remarkable efficiency gains. Our solution not only ensures space savings but also streamlines retrieval operations, perfectly aligning with the structure of pin codes. This translates to enhanced real time verification and scalability within our system.
We have created this demo website. This is a React web app. Over here, you can try out all the functionalities that our APIs provide. Like this is for demo purpose only. So you just have to go over here. Here you can try out both seller functionalities, like the APIs that are used for seller accounts and user accounts, both. For example, let's create an seller in our database. So let me just take the seller ID 4440 AF 1234 AF. And for this seller, let's create user pin codes. As you can see, these pin codes are like nearby only because they are differentiated with only large digit. So when we create this, this have inserted these pin codes to this particular user account. Let's say now we have this user account and we want to search for whether this user supplies in this particular region. So we will go for the user, and user each product have their seller accounts linked to it. So over here we can just check whether user supplies in his region. Let's say user belongs to this region, and when we search it, it will provide whether after entering the details, you just have to click on search. This will tell whether the user exists in this user supplies in this region or not. As you can see, this is a near real-time transaction, only even with the API call. This concludes the demo. As you have seen, we can directly uh, link this APIs in any of the apps, even in ONDC also. Now let us elaborate how this solution is working behind the scenes.
So whole thing works in three parts. First, we will represent the pin codes, the six-digit pin codes, as a tree, like what we have discussed previously. So the root of the tree will have -1, and it the root can have a maximum of 10 children. Each node will have a maximum of 10 children, as digit can range from 0 to 9, and we will be storing the specific digit like which is present with us in that children. So considering we have 543211 and 543212 in the root node, we will in the children section we will store 5 as it is it is the first digit in our pin code. In the node 5, we will store 4 because it is the second digit that is present to us. So, and the next digit will be 3, which will be stored as children of 4. Again, we will store 2 as children of 3, and we will store 1 as children of 2. Now, you can notice that this is changing. Like we have 1 and 2. So, here, the previous node, that is the like 1, will have two children, that is 1 and 2. So instead of saving 5 multiple times, we have saved it only a single time. This novel approach like saves a lot of memory and like this reduces the time it takes to retrieve it. Like we don't have to go through all the pin codes. We just have to look up for the seller, and in the seller we have like we have to go through only like the digits 0 to 9. So this is how our tree will represent in memory. So basically, the children of root node is the first block. This is an array of nodes, and the first node has like the node with the value 4 has a children, which is again an array of nodes, and in that array, like the node with value 5 again has the children that is consisting of multiple nodes, and this is going multiple times. So the first digit is represented here as 4, then 5, then 6, then 1, then 2, and then 3. So we are able to find the like this pin code in our tree. So this is how the tree is stored in our memory, like while the program has is active, like is in memory or is in RAM. But when we want to store this in database, then we have to convert this into binary, and then we will convert that binary string into ASCII characters, right? So this is our binary representation. Like considering like we are trying to store 4, 1, 2, 7, 8, 9. Like if we are trying to store 4, 1, 2, 7, 8, 9, then as you can see, this is a string of length 10, and here the index 4 is marked as 1. Other index are marked as 0. Like 4 and 5 are marked as 1, and other index are marked as 0. Now, if you see the one index, fifth index, sixth index, and eighth index are marked as 1. Others are marked as 0. Now, if I want to travel this path, like for like this path actually, then I have to go through like 4. Then I check the presence of fifth. Like if I travel want to like if I want to check is 4, 5, 2, 7, 8, 9, is this pin code available for some seller like A23 CF3? Like if I want to check this, then I will check, okay, uh, is the fourth index of the first set of binary digits, is it 1? If it is, then is the second index like is the fifth index of the second binary string, is it 1? Yes, it is. Then I will check, is the second index of this string, is it 1? If it is, then I will go through this, and finally I will reach the like end. And if the level I have reached till level 6, then I can surely say that yes, this seller is delivering to this pin code. So the next step is binary string generation. This tree which we have generated in the previous step, we will traverse it and generate a string which will have zeros and ones only. We will for the first level, that was 5 in previous case, we will create a string of length 10, which will have all zeros, and we will mark the fifth index as 1. So all the other index are zeros. So this represents that the first level of the tree has like only digit, that is 5, and the consecutive zeros will represent that what other digit are marked as like what other digit are present. So we will be marking like 4 and 3, like the fourth index and third index of the string of length 10 as one, and the rest of the digits will be zeros. So this is how the binary string will be generated. Through generating binary strings, we will be able to like store this anywhere, like because we the data base size is huge, so like loading this all in the memory will be tough technically, and it is also not feasible, like loading 10 million records. So we will have to store it somewhere. So this is how we are approaching this problem. And also after this binary string is generated, we will divide it into chunks of 8, and like the first 8 digit will be converted into ASCII character, and we will be only storing the ASCII character. So like it will be represented in a more efficient way in the database.
These are some key features and achievements that our solution have achieved. Uh, First, let's go with the scalability. Our solution is designed to scale seamlessly, accommodating large volumes of data without compromising on performance. Similarly, it is also efficient by we are using tree structures that significantly reduces time and resources required for both storage and retrieval. It is extremely adaptable as it allows it is basically API based and can be easily adapt and anybody can easily adapt them in their own solutions. In conclusion, our solution presents a paradigm shift in the way pin codes are managed and utilized. By harnessing the power of tree structures, we have unlocked an unprecedented efficiency gains, paving the way for more streamlined and scalable approach to data management. Thank you for your attention, and we are eager to hear your feedback and answer any questions you may have. You can reach out to us through our website or the details provided by the team.